Chapter 6 deals with rational functions, and in 6.1 we're going to introduce the concept of a rational function and also a rational expression. So we'll start with a couple of basic definitions. So a rational expression is just an expression that has the form p of x over q of x, where p of x and q of x are polynomials. So it's a polynomial over a polynomial. And a rational function is when we define a function f of x to equal an expression like p of x over q of x. So rational expressions and rational functions are very similar to each other. One is just the expression all by itself, and the other is when we define a function to be equal to that expression. And in either case, we need to remember that the denominator q of x cannot be equal to 0 because we are not allowed to divide by 0. So let's start with some basic examples. So here we have the rational expression, x squared minus 9 over x plus 4. You could even say x squared minus 9 divided by x plus 4. But usually I use the word over instead of divided by, because we're not actually going to divide these, at least not yet. Now, one thing to keep in mind here is each time you have a rational expression, you need to be concerned about the value of x that you are not allowed to plug in to the expression. So in this case here, it's pretty simple to see that you cannot plug in x equals negative 4 because negative 4 plus 4 would be 0. So let me just state that. In this case, x cannot be equal to negative 4 because the expression is undefined here. So any other value of x can be plugged into this expression, but you cannot plug in negative 4. In our second example, we have x squared minus x minus 6 over x squared minus 25. So this is another example of a rational expression. And this also has some restrictions. And one of the things that you'll need to do from time to time is you'll need to factor the denominator to find those restrictions. And so if we go ahead and factor the denominator, x squared minus 25, which is the difference of two squares, factors like this. And the numerator is also factorable, but I'm not going to focus on the numerator because for right now, I'm only concerned with doing examples of rational expressions and also identifying what value of x you cannot plug into it. So it's pretty simple to see, I hope, that x cannot be 5 because 5 minus 5 would be 0 and you would therefore be dividing by 0. But also x cannot be negative 5 because negative 5 plus 5 is 0 and that would also cause you to divide by 0. So this rational expression actually has two restricted values. So you can plug in any value of x as long as it is not 5 or negative 5. And our final example of a rational expression here, 3x plus 2 over x squared plus 1, has no restrictions. And this is because there is no value of x, no real number x that you can plug in here to make the denominator equal to 0. You can try if you want, but any number you plug in, when you square it, it becomes positive, and when you add 1 to a positive number, you will never get 0. So this expression actually has no restrictions. Moving on to rational functions, we'll basically have the same conversation here. So f of x equals the rational function x minus 5 over x plus 3. A rational function is just a function, f of x equals a rational expression. And once again, there is a restricted value here, right? X cannot be equal to negative 3. So when you have a function, you can state that one of two ways. We can say explicitly x cannot be equal to negative 3, or we can also write that as a domain for the function. Now the domain is all of the values of x that you can plug in. So if you think about a number line with the number negative 3 on that number line, if x is not equal to negative 3, that means you can plug in any number to the left of negative 3, or you can plug in any number to the right of negative 3. And so if we state this as a domain of a function, we would say its domain is all the numbers from negative infinity up to negative 3, union all the numbers from negative 3 to positive infinity. And this is just a sort of complicated way to say x can equal anything less than negative 3 or anything greater than negative 3. It just can't be negative 3 itself. And so stating either the restriction or stating its domain, these are equivalent, just two different ways to talk about the same thing. Now let's look at the function g of x, which is x squared minus 9 over x squared plus x minus 20. So again, if I want to state the restrictions or state the domain, what I need to do here is I need to factor the denominator. So numerator I will leave alone for now. The denominator is a trinomial, and I'm going to skip all of the semantics of factoring here, but you should end up with x plus 5 times x minus 4. And from there we can say the restricted values are x cannot be negative 5 and also x cannot be positive 4. I hope that's clear to you. Again, negative 5 is restricted because negative 5 makes this factor 0. Positive 4 is restricted because positive 4 makes this factor 0. So there are two restricted values. Now in terms of stating the domain of this function, we'll just go ahead and graph a number line with our two restricted values. And we're saying that x cannot equal these two numbers. So we can have any number to the left of negative 5, any number in between negative 5 and positive 4, plus any number to the right of positive 4. So if I'm thinking of this as a domain of a function, we can have any number from negative infinity to negative 5, or any number from negative 5 to positive 4, or any number from positive 4 to positive infinity. Now, please understand that these concepts are very simple. It's all because we cannot divide by 0. It's only when we start talking about these things using a mathematical language that it begins to sound more complicated than it really is. For our next set of examples, what we want to do is simplify these rational expressions and also give the restricted values. Now, always start with the restricted values because sometimes restrictions will appear to go away, but your restricted values always need to be based on the original problem. So for example here, we know x cannot be 0 because 15 times 0 would be 0. So x equals 0 is a restricted value, which means x cannot be 0. Now, in terms of simplifying, what we're looking to do here is cancel common factors. So 5x squared, we can think of that as 5 times x, and 15x is 3 times 5 times x. And any number divided by itself is equal to 1. So 5 divided by 5 cancels, and x divided by x cancels, and we end up with the simplified expression x over 3. So we're saying the original expression here is equal to the expression x over 3 as long as x is not equal to 0. Now, if you look at the final answer here, you can see that there is no x in the denominator, and therefore you might think, well, what's wrong with plugging in 0? Well, again, the restricted values always come from the original expression, not the simplified expression. Okay, for our second example, very similar here. Notice that this has two variables, both x and y, and since these are all multiplied together, both x and y cannot be 0. So our restricted values are x cannot equal 0, and also y cannot equal 0. And now for simplifying, all we need to do is factor these expressions. So we have 33, which can be thought of as 3 times 11, and then times x, and then times y cubed. Now, I can write y cubed as y times y times y, but let me just keep it y cubed. In the denominator, we have 11 times x squared, which I'm going to leave as just x squared, and then times y. And then let's remind ourselves that when there is no exponent visible, it's automatically a 1. So now when we go to cancel, 11 divided by 11 cancels out. And when you come to the x's, this x to the 1 here will cancel one of these x's down below. So we can cancel this and then just reduce that power by 1. And likewise, this y to the 1 here will cancel one factor of y in the numerator. And so that y will cancel this 3 here and turn it into a 2. Now you have to be careful when you're crossing things out because sometimes it's a little hard to see what's left. But in the numerator we have a 3 and we have a y squared. And in the denominator, what we have left over is just x. And this is a simplified expression of the original. For our third example, you have to be really careful that we don't cancel in the same way that we did here. Anytime you have a plus or a minus involved, you have to factor the expression. So in the denominator, we can factor this by pulling out a greatest common factor. And the greatest common factor of 10x squared and 20x is 10x. And when you factor out the 10x, we get x minus 2 left over. And in the top, we have 15x. Now that these are factors instead of terms, we can go ahead and cancel. So we know that x divided by x cancels out. And we also know that 5 goes into 15 and 10. So we can cancel a common factor of 5 here. And when you do that, you have a 3 left over in the numerator and a 2 left over in the denominator. And so the final simplified version here is 3 over 2 times x minus 2. Now, what about our restricted values? So if you look at this, you can see pretty clearly that x cannot be 2 because 2 minus 2 would be 0. So it is correct to say x cannot equal 2. However, that's not the only restriction because when we factored this, we used to have an x here. And because of that x right here, x cannot be 0 because if you plug 0 in here, you get 0 for the entire denominator. So there is an additional restriction of x cannot be 0. So this is why it's always best to find your restrictions before you actually simplify, which I actually didn't do in this problem. Okay, let's move on to some others. So for the rest of these problems here, we're just going to simplify and state the restrictions. Now, when you're simplifying, what you need to do is factor both the numerator and the denominator. And I'm not going to do the magic X for every single problem that we do. I'm going to rely on the assumption that you guys know how to factor somewhat at this point. And so to simplify this problem here, what we need to do is factor x squared minus 16. Now that's the difference of two squares, which factors pretty easily into x minus 4 times x plus 4. And then the denominator is a trinomial. And so to factor this, there's a 1 here. So we're just looking for two numbers that multiply to give us negative 12 and that add to give us positive 1. And so that's going to factor into x plus 4 times x minus 3. Now that we have it factored, we can go ahead and state our restrictions. So x cannot be equal to negative 4 or positive 3. Now that I've gotten my restrictions, I can go ahead and simplify by canceling the common factor. And what we end up with here is x minus 4 over x minus 3. So this is our simplification of our rational expression, and these are the restrictions. Moving on to the next problem. It's the same idea. So I'm going to start by factoring. So the numerator factors. We're looking for two numbers that we can multiply to get positive 4 and add to get negative 4. So that should be negative 2 and negative 2. And in the denominator, we are looking for two numbers that we can multiply to get positive 12 and add to get negative 8. And that would be negative 2 and negative 6. Next, we'll state our restrictions. T cannot be equal to positive 2 or positive 6 because it makes each of these factors equal to 0, respectively. And then finally, we can cancel. Now, notice we have a t minus 2 down here, and we have two factors of t minus 2 in the numerator. It doesn't matter which one you cancel out. But what we have left over is t minus 2 over t minus 6. Okay, let's move on to the next one. Now, this is given as a function, but if I want to simplify this, it's the same steps. I need to factor the numerator, and I need to factor the denominator. And I'm going to work on those separately. So we'll come back up here and we'll put in our factorizations when we're done. But let's start with the numerator. X cubed plus 64 is the sum of two cubes because 4 to the third power is 64. So you have to remember how to factor the sum of two cubes. We should know that it's a binomial times a trinomial. And we should know that the x plus 4 goes into the binomial. And then to get the trinomial, we take the x here and we square it. That gives us x squared. We take the 4 here and we square it, which gives us positive 16. And then to get the middle term, we multiply these together. 4 times x is 4x. And the sign here will be the opposite of this sign. And so it's negative 4x. So that is the factorization of the numerator. So we can go ahead and fill that in here. And then the denominator also factors, but it factors a little bit differently. So let's look at the denominator now. X cubed plus 4x squared plus 3x plus 12. And we're going to factor this by grouping. And out of the first two terms, we can pull out an x squared, which leaves us with x plus 4. Plus, out of the second set of terms, we can pull out a 3, which also leaves us with x plus 4. And now you can see we have a common factor of x plus 4. So we get x plus 4 times what's left over, which is, of course, x squared plus 3. So that is the factorization of the denominator. Now, just a quick comment. X squared plus 3 is not factorable, so this is where it ends. Now, for our restrictions, x cannot be negative 4. Because if you plug in negative 4 here, you get 0. There are no restricted values for x that come from here because it's impossible to make this expression equal 0 plugging in real values for x. So negative 4 is our only restriction, and now we can simplify. And so our final answer here in simplified form is this. But again, what's really challenging for most students in this section isn't the actual simplifying. It's fairly simple to cross out two factors once you see that they are the same. The challenge is the factoring. So you need to be good at factoring. Okay, so now we're going to move on to the next section, which is kind of a continuation of the last one. So in 6.2, we look at multiplying and dividing rational expressions. And this is really similar because when you multiply two fractions together, you can do things like cross-cancel if you have common factors. So the technique for doing this is very similar to what we just did. What you need to do is factor the numerator and the denominator of each of the fractions involved here. So 5x squared is 5x squared, but 5x plus 15 can be factored by pulling a 5 out of each of those and getting x plus 3 left over. And now we're going to multiply that by this fraction. And we can factor x squared minus 9 using the difference of two squares formula. And then that's over 20x. So now we can cross-cancel any factors that are the same. So x plus 3 here and x plus 3 here can be canceled out. And you can also cancel this 5 with either the 20, so we could cross-cancel there, or we can cancel this 5 with this 5. And actually, I think that's easier, so I'll go ahead and do that. And then one final cancellation we can do is the x squared here and the x down here. This one factor of x here will cancel out one of those factors of x. And so what we have left over, in the numerator here we have an x, and that's going to be multiplied by x minus 3. And then in the denominator, everything is canceled out here, and all we have left over here is this 20. And so the simplified version of this answer is x times x minus 3 over 20. And by the way, there are restricted values as well. Can you think of them? Well, if you look at the answer, you don't see any restricted values because there is no x down here. However, if you go up here, you can see that x cannot be negative 3, and also x cannot be 0. Okay, let's move on to the next one. So to simplify this expression, we're going to have to do a lot of factoring first. Do not multiply first. If you multiply these, you get a really large polynomial. Same thing here. So factor each one of these 4 polynomials first, then cancel, and the last thing you'll actually do is multiply. So here's what we have. Up here, we're going to factor this trinomial, and I am going to skip the explanation of that. In the denominator, we have a difference of two squares. In the numerator here, we have another trinomial. And in the denominator here, we also have a trinomial. And it factors like this. Now, what's really important when you're doing these problems is before you start canceling things out, make sure that all your factoring is done correctly. Then we can cross cancel. So a minus 3 cancels with a minus 3. A minus 4 cancels with a minus 4. And after that, there are no other common factors that we can cancel. So what we have left over in the numerator is a plus 2 times a plus 2. And in the denominator, a plus 4 times a plus 5. This is an acceptable solution. You could leave it like that. However, most of the time, this will be rewritten as a plus 2 to the second power over a plus 4 times a plus 5, because that is a slightly simplified version. And just to play devil's advocate here, another way you will sometimes see this answer written will be they will multiply out these polynomials here. And if you do that, you get the following. All of these answers are acceptable. Personally, I think this one here is the best. But I want you to understand that all of these are okay, because we've done the simplifying. We've simplified as much as we can. Okay, the last thing we're going to look at is division. Okay, so in this first one, we have this rational expression here divided by this expression here. The important thing to remember is that we don't ever actually divide by a fraction. What we do is we multiply by the reciprocal of the fraction. And so by definition here, this becomes 2x squared minus 2x minus 12 over x squared minus 4 times x squared minus x minus 2 over x cubed minus 9x. So I reciprocated the second fraction and changed division to multiplication. Now I need to factor. Now the factoring here involves pulling out a greatest common factor, and the factoring here also involves pulling out a greatest common factor. Here we have a difference of two squares, and here we have a trinomial. I'm not going to explain all of the factoring here, but I'm going to pull out a greatest common factor of 2 in the numerator. The denominator is a difference of two squares, which factors pretty easily. The numerator of the second fraction is a trinomial, which I can factor using trial and error. And the denominator has a common factor of x, and when I pull out that x, we get x squared minus 9 left over. So now we just need to factor x squared minus 9, which is the difference of two squares, and this trinomial here. And so in doing that, the numerator of the first fraction becomes 2 times x minus 3 times x plus 2. The denominator is the same. And the second fraction has the same numerator, and the denominator becomes x times x minus 3 times x plus 3. Now all we have to do to finish is cancel out the common factors. So there are quite a few that we can cancel out. first you should see that x plus 2 and x plus 2 cancels. Then there's an x minus 2 and an x minus 2 here that we can cross cancel. And x minus 3 and x minus 3 here we can also cross cancel. And that's it for the common factors. So what we have left over now is our answer. In the numerator we have 2 times x plus 1. And in the denominator we have x times x plus 3. And this is our final answer. Now for our last problem, it's also very similar to the one that we just did. We have division, so the first thing we need to do is we need to change that division to multiplication. So we have x squared minus 36 over 10 multiplied by 2 over 3x plus 18. Then we're going to go ahead and factor each of these. So x squared minus 36 is the difference of 2 squares. 10 I'll just leave alone as 10. We're going to multiply that by 2 over, and then down here we can pull out a common factor of 3. And after doing that, we can cancel common factors of x plus 6 here. And there is a common factor between 2 and 10. 2 goes into 2 1 time, and 2 goes into 10 5 times. And so what we have left over in the numerator is just x minus 6. And in the denominator, we have 5 times 3, which is 15. And this is our final answer. Please do not cancel the 6 with the 15 because these are terms, not factors. So the name of the game in both section 6.1 and 6.2 is factoring. You have to be good at factoring. All right, let's get some practice.